Hello students, let us start with the first chapter, Determinant, the introduction to Determinant. Today, the 14th May 2020. In this class, we shall see how a determinant came into existence, how to calculate value of a determinant, and what are the properties of a determinant. For this, first we consider two linear homogeneous equations, a1x plus b1y equal to 0, a2x plus b2y equal to 0, where x and y are variables or unknowns, a1, b1, a2, b2 are constants, that is real numbers. Clearly we see that if we put x equal to 0 and y equal to 0, then both the equations are satisfied. Therefore x equal to 0 and y equal to 0 is a solution. This solution is called trivial solution or obvious solution or zero solution. And in this case, a1, b1, a2, b2 may not have any relation among themselves. But this system may have a non-zero solution also. Suppose this system has a non-zero solution. That is, at least one of x or y has a non-zero value, satisfying both the equations. And let the value of y is null. In this case, we shall see that there is a relation among the coefficients a1, b1 and a2, b2. How? From equation 1, a1x equal to minus b1y, that gives us x by y equal to minus b1 by a1. Similarly, from equation number 2, we get x by y equal to minus b2 by a2. Therefore, minus b1 by a1 equal to minus b2 by a2, equating both the values of x by y, or a1 b2 equal to a2 b1. Or by side changing, we get a1 b2 minus a2 b1 equal to 0. We mark it number 3. And this is the relation among the coefficients obtained by eliminating x and y from the equations number 1 and 2. This left hand side a1 b2 minus a2 b1 of the relation number 3 is actually denoted by this symbol a1 b1 a2 b2 between two vertical lines, which is called a determinant of order 2 or second order determinant. Here the elements appearing in a horizontal line a1 b1 and a2 b2 constitute rows of the determinant, and the elements a1 a2 b1 b2, we see that they appear vertically and they constitute columns of the determinant. Here we get 2 rows and 2 columns. That's why it is determinant of second order. Thus, this determinant a1 b1 a2 b2 is equal to a1 b2 minus a2 b1, and this right side of this number 4 is called the expansion of the determinant in the left side. And this expansion is obtained by multiplying the element in the left up corner and that in the right down corner. Here it is a1 and b2, so a1 into b2. Then give a minus sign, minus. Then element in the left down corner into element in the right top corner, a2 into b1. So this is the process how we calculate it. And this a1 and b2 lie along as if along a diagonal, and this is called principal diagonal. You can call it principal diagonal. So principal diagonal elements are multiplied first, and then a minus sign is given, and then the other diagonal elements, you can call it off diagonal, they are multiplied. So this is the process of calculating value of a second order determinant, and this process can be remembered from these arrow symbols. We note that eliminating x and y from the equations 1 and 2, we get actually relation number 3, and the left side of 3 is the determinant. Therefore we get here determinant equal to 0. Here we see that positions of a1 b1 a2 b2 are exactly similar as their positions in the system of equations. As an example, let us calculate the value of this determinant 2, 4, 5, 3. Here main diagonal or principal diagonal elements 2 and 3. So 2 and 3 multiplied first, 2 into 3, minus, by formula there is a minus. of diagonal elements 5 and 4. So 5 into 4. 2 into 3 minus 5 into 4 minus 14. Similarly, number 2, 3 you see. Let us see number 4. Here principal diagonal elements are 0 and 3. So 0 into 3 minus 5 into 4. There is a minus sign in the formula and there is a minus sign before this element. That's why 2 minus sign, and this gives us the value, positive value 20. This is how we calculate value of a second order determinant. Now let us see how a third order determinant came into existence. For this we consider three homogeneous linear equations in three variables x, y and z. In this case also, x equal to 0, y equal to 0, z equal to 0 satisfy all these three equations, and this is a solution, trivial solution or zero solution. But we assume this system has a non-zero solution. That is, at least one of x or y or z has a non-zero value. All may be non-zeros. Now, from the equations number 2 and 3, by cross multiplication process, we get x by y by z by. This process we have learned in class 9. Still, let us see again. X by, when we write x by, we ignore the first column here. Then b2c3 minus b3c2 x by equal to y by. When we write y by, ignore the second column. But in this case, we multiply in reverse order. Here it comes a3c2 minus a2c3 equal to z by, we ignore third column and again in previous order, a2b3 minus a3b2. So this is the process of cross multiplication, you learned in class 9. Here we have written denominator of y slightly differently, taking minus sign common, and then each of the ratios equal to ksa. Here k is not 0 because we have assumed x, y, z are not all 0. Now from this we can find the value of x as k into denominator of x, y equal to k into denominator of y, z equal to k into denominator of z. And these values, when substituted in equation number 1, they should satisfy equation number 1 because they are simultaneous equations. All the equations should be satisfied by the same values of x, y and z. And putting these values in number 1 and cancelling k, we get this number 5. One expression equal to 0. This expression in the left side of number 5 is denoted by this determinant, third order determinant. First row a1 b1 c1, second row a2 b2 c2, third row a3 b3 c3. The positions are exactly same as in the system of equations a1 b1 c1 etc., which is called a third order determinant or determinant of order 3. Thus, eliminating x, y, z from the above three equations, we have got number 5, but left side of number 5 is actually the determinant, so we get determinant equal to 0. And this result will be used frequently in solid geometry while writing the equation of a plane. Eliminating unknowns, we get a determinant equal to 0. Thus, the determinant, third order determinant, above third order determinant is equal to this expression number 6. This is the expansion of the determinant, and this is the expansion with respect to elements of first row. a1 into minus b1 into plus c1 into. Using the notation of second order determinant, this b2c3 minus b3c2 can be written as the determinant b2c2 b3c3. Similarly, this a2c3 minus a3c2 can be written as a2c2 a3c3 determinant, and this a2b3 minus a3b2 can be written as a2b2 a3b3. Now, how this is to be written? Easy to write. a1 into omit first row, first column, remains b2c2 b3c3. So this determinant is written here. Then minus b1 into omit first row and second column, because b1 appears in first row, second column. What remains? a2c2 a3c3. C a2c2 a3c3. Similarly, c1 into written, omitting first row and third column. And this is the expansion of a determinant of order 3 with respect to elements of first row. Now this line number 6 again written here, and second and third terms we have slightly modified. Here B1 and C1 were outside, now we have taken A2 outside and A3 outside. Slight arrangement. Values are same, only we have written in different way. Means this determinant now A1 into second order determinant minus A2 into second order determinant plus A3 into second order determinant. What happens? Previously it was A1 into minus B1 into plus C1 into. Now it becomes A1 into minus A2 into plus A3 into. Means this is the expansion of the determinant with respect to the elements of first column. A1, A2, A3 appears in first column. Very easy to write. A1 into what determinant? Second order determinant, omitting first row and first column. We have got. Now minus A2 into second row and first column omit, get B1 C1 B3 C3, B1 C1 and B3 C3 here. Similarly A3 into third row first column omitted, we have got B1 C1 B2 C2. So this is the expansion obtained in terms of first column. Similarly, a determinant can be expanded with respect to elements of any row or any column. You can expand in terms of third row, you can expand in terms of second column, like that. For example, I have expanded here, it is in terms of second column. Here first element of second column is B1 minus B1 into first row second column omitted, so what remains? A2 C2 A3 C3. If we expand it, A2 into C3 minus A3 into C2, it is given there. Then plus B2 into second row second column omitted, A1 C1 A3 C3, multiply A1 into C3 minus A3 into C1, get it. Similarly minus B3 into. Now there may a question arise, why it started with minus B1? The sign before an element is obtained by this rule. B1 appears in first row second column. First second means 1 and 2. Minus 1 to the power 1 plus 2 is minus 1 to the power 3. That's why it is started with minus B1. That is, if an element occurs in ith row and jth column, then the sign before this element will be minus 1 to the power I plus j. Here B1 occurs in second row, first row second column, and that is why the expansion starts with minus sign, and then alternately plus and minus sign will come. If you find the sign of before one element, then the next element will be opposite to that previous element. Like this also can be written easily. We note that the value of this above determinant will be easily obtained if B2 and B3 are 0. Suppose B2, B3 0, then what happens? Second term, third term you need not calculate. Just calculate the first term, and value is easily obtained. And that is why to calculate the value of a determinant, what we shall do? We shall expand it in terms of that row or that column in which more number of zeros appear. And if all the elements in a row or a column are 0, then obviously the value of the determinant is 0. As an example, let us calculate value of this determinant. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 1 into first row, first column omitted. Then what remains? 5, 6, 8, 9. Second order determinant. Minus 2 into first row, second column omitted. What remains? 4, 6, 7, 9. See, 4, 6, 7, 9. Plus 3 into first row, third column omitted. 4, 5, 7, 8. 4, 5, 7, 8. Now expand with the rule of expansion of second order determinant. Here it is 5 into 9 minus 8 into 6. Here 4 into 9 minus 7 into 6. Here 4 into 8 minus 7 into 5. And then calculated value is 0. Now as another example, let us calculate value of this determinant. Here we note that second column contains 2 zeros. So let us expand in terms of second column. In that case, what we do, we start with this second element. It is first or second column, that's why it comes with starts with minus. Minus 0 into anything we are not writing, plus 0 into anything we are not writing. Then third element is 8, minus 8, but already there is a minus sign by expansion rule. So minus 8 into, omitting third row and second column, we get 1 minus 3 4 6. It is written, and expanded we get the value 144. And today we stop up to this. Thank you. In the next class we shall see what is the definition of minor, cofactor and properties of determinant.